we're supposed to look at? Oh, no, 103. Oh, and there's one. All right. So today, main thing we want to get done today, emphasis continuing on, all of chapter 1 is based on graphs and functions especially, and if something is a function. And so we want to really focus on domain and range. Domain and range, zeros of a function, which really just means the x-intercepts. Even odd functions, what that means, it's related to symmetry. And then what we call elementary. I hate to use the word elementary because it makes it seem like it should be so easy, right? So if you have a tough time with it, but basic, that's not a whole lot better. Your book calls them parent functions, kind of the. But again, there are these categories of different functions that we should know at this point. We're going to add to that list as we go through the year of these different functions, like exponential functions, which I know you worked with last year, log functions, which I know you did some stuff with logarithms last year. And then, of course, the big one that we're going to do this year is trig, the trig functions. And you've done a little bit of a sine, cosine, and geometry class and so forth, but we're going to spend a lot of time with trig functions. So those are the what we call the basic or the elementary functions that we have to know going into calculus, because then we work calculus on all of those functions. But we've got to know how those functions, what those functions look like, and the different aspects of those functions, the different properties of those functions, if we're going to be able to figure out calculus on them. Okay, so besides 96 and 103, what else do you have a question about? Now again, think to yourself, okay, what if this was a quiz question? What if this was going to be on the quiz? Do I really understand what's going on? Or should I maybe ask a little bit about it? What's going on? Like you had those ones we talked about at the end of class yesterday, is it a function, yes or no? Well, a good way to do that is to solve for y. If you don't have a graph to look at, we talked about the vertical line test, but if you don't have a graph to look at, what can you do? You take the equation, solve it for y. And if it's got a plus minus in it, that's a dead giveaway, which usually comes from a square. If you have a y squared, when you get the y by itself, you're going to get a y equals a plus minus something, and that means you get more than one output for one input. It's not going to be a function. I mean, that's pretty much what you're looking at. All right, anything? Jack?
So on 34, it just says y equals negative 75. It's just a straight up function, just because it gives you the...
That would be this horizontal line right here, right? Down here at negative 75. Every input has only one output, right? So it's a function. Matter of fact, it's one of our basic functions. It's called a constant function. A constant function, any horizontal line. Yes?
On 46b, it's 2t squared plus 3 over t squared. You have to plug in 0.
Right.
So if you do that, you get 3 over 0.
And so for the answer, so when it says evaluate the function, which were the directions, and simplify, so evaluate means find the value. In that case, there is no value, so say undefined.
Okay.
So go ahead and say undefined. Okay? Because when we talk about a function, technically, what you get here, now it was not f of x, it was t. Which one were you saying, 46? Actually, it was q. Q of t equals 2t squared plus 3 over t squared. So another way of saying that is the definition of that function, right? That's what that function is defined to be. And so when you ask for q of 0, and you see you're dividing by 0, we just say that value is not defined in this function. And it's because 0 is not in the domain of this function, right? We were talking about that yesterday. The implied domain or the natural domain. So this is a function with this as its rule, as its definition. That is what assigns any output value to a given input value. But for 0 as an input, there is no value assigned to that. Because when you put in a 0, you don't get a value out. Because dividing by 0 is not a number, not a value. And so we just say undefined. Okay? What else? Yeah.
The 43c, put the x in absolute value for the answer. After you got 4 squared.
Okay. So you got f of y, and that's kind of an interesting choice because we don't often use y as an input, but we can, right? I mean, a lot of times x is our input, y is our output, but it doesn't have to be that way, right? So for this particular function, the function value is f, and the y is our input, right? So y is x our input. Well, and before I continue and finish your question, it just reminded me of something. So let me go on a little side trip here and talk about something. Again, in calculus, so when you hear me talk about inputs, outputs, stuff like that, understand that typically with function notation, we just assume this to be true. In other words, where we see f of x, think of that as your y. Think of that as your output. So in Algebra 2 class, you spend a lot of time talking about ordered pairs. So let's say we had the equation y equals x cubed, or likewise we could say f of x equals x cubed. We're going to talk a lot about that today, right? When you write it as just a relation between x and y compared to you write it in function notation. They're very, very much the same thing, okay? So there's just some little differences notationally that we want to be aware of, okay? And so what's nice about function notation is I can plug in a 2 by doing this, right? And I get f of 2 equals 8, and we know that. With this way of doing it, I don't have a great way of writing that, so what we typically would do is an ordered pair, right? We would write it like this. So in algebra class, you're used to writing points on a graph as ordered pairs. In calculus class, we usually do not do this, well, even in this class, because to be honest, what can 2, 8 also mean that we've been working on? What could this mean?
2 is plus.
The interval from 2 to 8. So this could mean this, right? It depends on the context of the problem. So this could mean an ordered pair on a graph, but it could also mean this interval. So a lot of times in calculus, if we want to talk about a point on a graph, if it's a function, we just do that. And that's the same thing, right? This is giving you a point on the graph. 2 is the input, 8 is the output. 2 is the x, 8 is the y, right? So just understand that notationally what's going on. Okay, back to this. So we have this, and you're supposed to find f of 4x squared, right? Is that the one, Jack?
Yeah.
So that means take this and put it in for the y. So that means right there. So we're going to get 3 minus the square root of 4x squared. Now the direction said to simplify. So we talked about this the other day. When you do square root of 9, that is 3. Not plus or minus, just 3, right? It's only plus or minus if you add something like this. X squared equals 9. You were solving that. That would be plus or minus 3. So square root of 9 is 3. So I think we did talk about this. What is the square root of x squared? You'd think that would be just x, but what is it? No, it's not plus or minus. It's, well, what could x be here? Could x be a negative? Careful. Now I know what you're thinking, because we've said this in here already. We can't have a negative inside the square root. Now that's not very good language on my part. You can't do a square root of a negative 3, right? But I could have a negative inside of a square root. Couldn't I do this? Isn't that okay? The square root of negative 3 plus 6, can't I do that? Because what is that? That's a square root of 3. So it's not really right to say you can't have a negative inside the square root, right? So understand what I mean by that. So if I put a negative 3 in here for x, what's negative 3 squared? 9. And then what's the square root of 9? 3. So so if x is negative 3, was our answer x? Did our answer come out negative 3? It came out positive 3, didn't it? Right? Now if you put a 3 in there, 3 squared is 9, square root of 3, or square root of 9 is 3, yes, you do get x back out. So you put x in, you get x out. But if you put a negative in for x, you do not get x out. You get the absolute value of x. And so that's why they put absolute value around it. When you have an x inside that square root like that, and you do the square root of it, it's going to give you a positive value. And there's nothing about this that says x has to be positive, right? X could be negative here. So when they do the square root of this and get 2x, they put absolute value bars around that x. Okay, all right, so that's something we want to be aware of, because that is a domain issue that we would want to make sure we took care of. Okay. On the scale of, easy and hard problems on the quiz, that would be a harder problem, right? That would be one that could potentially trip you up. So just be careful. That's one of the few. That's about the only time we have an absolute value is going to show itself is in a square root kind of situation. All right, so that's a great question. Okay, what else? What else? Okay, let's go on to 103 and 96. I just kind of worked out 103. Now, some of you didn't have much work shown on this one, and so you want to make sure you do. I don't know how else you're going to do this without having work shown. I mean, you just have an answer when I go around and look. And I always pick out certain ones that I know what probably your work should look like. And if you just have an answer on one like this, that tells me, probably just looked at that one up in the back of the book. Do your work right there on your paper, okay? So what did we say? We're supposed to find this difference. So we did one very much like this. So f of 2 plus h means take that 2 plus h and do what? Put it in for that x and in for that x, right? And so I've got that worked out over here. So I got 2 plus h squared minus, now make sure you get those parentheses. That just kills calc students all the time when we do this problem. Okay, forgetting to put that 2 plus h in parentheses there. Okay, and then plus 1. And now we FOIL that out and we get that. And we distribute that negative there and we get that. And so now when we combine those terms, we get this. And then we put a 2 in for x and we get that. And so now we subtract them. Up here, put the h on the bottom. Of course, those cancel out. And then we got the same answers we did yesterday, I think, didn't we? Was it the same problem? It wasn't the same problem, was it? A little different. Yeah. Okay. So we take out an h, we can cancel the h's, and it simplifies to that. Okay? So that's something you may have to do on the quiz. All right? Here's a function. Find this. It's nothing more than just plugging into the function, right? You guys would find that very easy on a quiz if I gave you that function, said find f of 2, right? That'd be a very easy question. This is not that much different. I mean, yeah, there's some FOIL and there's definitely some algebra parts to it to do. But the basic thing you're doing is the same idea. Putting in a 2 plus h everywhere you see an x. Putting in a 2 and then just simplifying. All right, let's talk about 96. We have matter of fact, we're in chapter 4 in calculus right now. We are going into the section where we work with these kind of problems right now. And interestingly enough, our book, calculus book, different author, total different publisher, everything has this exact same problem in it. And then we, except we don't graph it, we use some calculus on it to do some stuff with it. But the setup and everything is the hardest part of this problem for the calc students, and that's what you guys were supposed to do. Right? And so it didn't surprise me that we struggle on this a little bit. It's the first time we've seen it. So I went ahead and drew this picture of this box, which I think when you get a problem like this is probably a good first step. Okay, let me see if I can close it. All right, and they have the picture written down there for you too. So part A, write the volume of the package as a function of x. Now, I saw several of you have this on your paper. Now, I see very many people with this. Okay, but so let's just focus on this. So the volume. So I think a lot of you looked at it and said, oh yeah, that'd be base times width times height, x times y. So you have that. But is that a volume of x, or excuse me, is that a function of x? What should it look like if it's going to be a function of x? What should be on this side? Just x's. There should not be any y's. So let's understand the lingo. This is a function of x because on this side of the equal sign, there is nothing but x's. Okay? So when it says write the volume as a function of x, the first thought I would want to come to mind for you would be this. B of x. So let's think about that now, because that might come up on our next quiz, right? Write the function, write b as a function of x means b of x. So that means V is going to be our output, volume, and we want X to be our input. Well, that means we got to get rid of this Y. So in a problem like this, we would call this our primary equation, and then this would be a secondary equation or some additional info. Now in Algebra 2, you did something called linear programming. You talked about I can't remember the name. Linear programming, and you had to draw lines and you found the corners. Objective function, does that sound familiar? No? I must have dreamt that last night. Constraint equations, constraints. Oh, I'm asking Mrs. Andrews.
It's been like a whole year.
Yeah.
Huh? What? It's been a full year?
Yes.
Okay, all right. Well, it doesn't matter. The point is, we have some additional information in here about this particular box. It says that for it to be mailable, for it to be allowed, this package, the length plus the girth. Now they define the girth, if I read that properly, it said that the girth is the perimeter of a cross section. That means a slice, a cross section would be like here. Okay, well what is that perimeter around there like that? That's 4x, right? X plus X plus X plus X. Okay, so it's the length, which would be Y, plus the girth, has to be a maximum of 108. Okay, so that's the most it can be. So that's where I got this equation. Well, what can I do with that? What can I do with this equation? Because what we're trying to get down here is not have a Y in here. So can I subtract 4x from each side? And then do what with that? Substitution, right? It's just two equations, two unknowns. So we have this and we have this. And so now we can take the y and we can plug that in. So now we have x squared times 108 minus 4x. So if you couldn't get to there, obviously you weren't going to be able to graph it or anything else, and that's what happened to most of you, okay? So understand as we go through the year, I mean, it's the same with some of your Algebra 2 story problems, but this kind of thing. So one of the things we run into in calculus, there's no calculus here at all. This is just setting up an equation. This is just writing a function is all that is, okay? And they're going to struggle with it too, trust me. And as we do more of them, they'll get better at it, right? And hopefully you guys will see some of these and get better as well. So we want to graph that. Now we could go ahead and distribute that. That's 108 x squared minus 4x cubed. One of the things we're going to talk about today is understanding that that's a cubic function and what cubic functions look like. But anyway, so I've already got my Desmos, I've already got the graph up here somewhere. Here it is. So I went ahead and put that in. I had to really play around a little bit by plugging some numbers in to see what my window needed to be set at. Notice this goes all the way up to 10,000. Okay, but I wanted I really had to play around with my window to figure out what that was. And the nice thing about Desmos is we can just trace right along here. And what do you know? It finds these nice points for you. It found the maximum. I think that's the number you had, wasn't it? 11,664.
I had like 18.
But then it was, the volume was 11,664, right? So what this is the X value is 18 and the volume is 11,664, okay? And if you look at this, if the X value is 18, that would be 18 by 18. And if you put an 18 in here, 18 times 4 would be 72. 108 minus 72 is 36. And so it would be 18 by 18 by 36. Okay, and that would be the maximum size and the maximum volume you could have that would be allowed to be made. Now, in calculus class, we don't just graph it and just find this point. We figure out a way with the equation we can come up with that point. Okay, but with this calculator and doing this, that's nice to be able to see that pretty easily as well. Okay, but again, the calculus part's not hard on that problem. It's getting it set up. Trust me, every calculus student, once they get to here, they're fine. Piece of cake, okay? It's getting this part that we work a lot on. All right, so real quickly here, do these 5 problems. All right. Here are. Okay, so the domain was -2, 1, and 2, but, right, so those three things, the range, 2 was repeated, but that was fine. So it is a function, right, because each input only matches with one output, even though 2 is repeated in the range, that's fine. You can have, just like Jack asked about y equals -75, every number there had a y value -75, it was fine. Put in the -2 here, and you get 6 minus 4 is 2. Put an m in here, you get 5 is 2 minus m, that's it, right, just like that. And then put a 3a in for the x, 3a squared would be 9a squared. Now, did anybody, well, don't admit it if you did. Because if you did that, that's no good, right? We won't make you admit it to everybody. But the square root of 9a squared minus 4 is just that. You cannot do that. Okay, you cannot distribute a square root. That's what you'd be doing. A real easy check of that would be this right here. 9 plus 4, right, is not 3 plus 2. That is, the square root of 13 is not 5. So that doesn't work. So just in case you thought of that, okay, don't do that. All right? All right, moving on. Number 1, function yes or no. Number 2, yes. Okay, number 1, what would be the domain? All reals. Domain would be the possible x values. Well, this goes forever and ever. This goes forever and ever this way. So you have x's you can put into everything. We can have a domain of a relation. Even though it's not a function, we can still talk about domain and range. What's the range? All reals. It's going to hit every y value down to negative infinity and every y value up to there. Okay. Function, yes. What's the domain? All reals again. The x's are all reals. We're going to put in values all the way from negative infinity to infinity. What about the range?
Y is less than or equal to 0.
Y less than or equal to 0. Or you could say negative infinity to 0, like so. And make sure you do it that order, not 0 to negative infinity, right? It's from little to big. So negative infinity to 0 is our range. You can put that either way. Okay? All right. Function yes or no on 3?
Yes.
Yes. 4? No. Domain on 3? It's not all reals. The hole right there. Does -1 have a y value? -1 does not have an output. There's a hole there. Okay, and there are, you say, what kind of graph would that look like? What kind of graph would have a hole in it like that? Well, this particular graph right here, let's see, over 1, down 3, that would be, well, I'm not going to. This right here, if you were to graph this right here, this would look like this would be this graph right here, and it would have a hole right there. It would just be a line, and it would have a hole in it. Why? Because if you FOIL this, what's going to happen? X plus 2, x minus 2, over x minus 2, those are going to cancel, right? Now, in algebra class, you would say that this is equal to the x plus 2. Now, that's technically not true, because in this one, you can plug a 2 in, and what do you get? 4. In this one, can you plug a 2 in? No, because you get dividing by 0. This graph looks the same as the graph of x plus 2, except it has a hole at 2. This one does not have 2 in the domain. This one does not have -1 in the domain. So this would be all reals except -1. Okay? This one, the domain would go from what? 1 to 7? From 1 to 7. The range looks like it's down here, -3 to +3. Kind of thing, right? So with graphs, I think domain and range are pretty easy to do. Graph, domain, and range are pretty easy to do. You can look at those. Okay, here's another one. All reals except 1, 2, 3, 4, 5. X cannot equal 5. There's no output for 5. But what about the range on one with a hole? Let's go back. What about the range on this one, number 3? What's the range? What are the outputs? Everything but, and we're talking about the y's now. 1, 2, 3. Every y value will get hit except 3. So you would say y would not equal 3. Or you could go negative infinity to 3 and 3 to infinity. Okay, but now on this one with the hole, x cannot equal 1, 2, 3, 4, 5. X cannot equal 5 because you put in a 5, there's no y value. What's the range though? Do you have to leave out the y equals 1 there in the range? No, because what about right here? Doesn't y equal 1 right here? And y equals 1 over here, right? So every y value from negative infinity to infinity is going to get hit in this graph, okay? Even though there is that hole. So therefore the range here would be all reals, okay? All right, so we've got, here's some other graphs. We're going to talk about a graph like this here in a little bit. All right, so moving on. All right, so let's take a look at this PowerPoint. Okay, so the next thing we want to talk about is finding the zeros of the function. Here we go. Zeros of the function, okay? So we've talked about domain and range a little bit. If we go back to what we talked about at the beginning of class, we said we want to talk about domain and range. We did that a little bit. Now we want to talk about zeros of a function, okay? So zeros of a function, if we look at these slides right here, the zeros of the function are the values where f of x equals 0. That is the y equals 0. Well, that's the same as x-intercept. So zeros of a function are the same as the x-intercept of an equation, okay? Zeros of a function are the same as the x-intercepts of the equation. Well, hi there, Dr. Evans.
What's going on, Mr. Clark? I feel I can do this now.
Superintendent. Clark Public Schools.
Yeah, I just want to stop by and grab stuff. Don't like it, but felt like I wouldn't run into you or something like that. Go back during long ways back. Long way back. Yeah. So, young guys, but you're a pillar. These guys probably don't recognize that, probably don't acknowledge that.
This is just the boring guy I have time to listen to before we go to lunch.
Everybody's, how many minutes to lunch?
17.
Not 15, not 20, no. 17.
No, just as superintendent, I know these guys know it too, just indebted to you. Excited for you, proud of you, can't believe. Consider, all that stuff's a 2-part process, submission and approval.
I know.
Consider, had some inside help that was willing to do it.
Yeah, I know. I texted our HR director and said I saw the minutes and I saw the approved. So
Anyway,
I couldn't do it fast enough.
I hate to interrupt you, but now we're down to about 15 minutes. You want me to keep going? Is that right? So, I'll just mess with you. I'll talk to you later.
Thanks.
No, it's
All right. So anyway, where were we? Oh, zeros of a function. All right. So here is, okay, don't look, close your eyes. Close your eyes. No. Good job. One person. All right. Find the zeros of those 3 functions right there. Find the zeros of the function, right? Zeros of the function means set the y value equal to 0. Okay? Or set the equation equal to 0 and solve. Go. there's the answer to the first one. 5/3 and -2. All right, factor. 3x minus 5x plus 2. Okay, what about for B? How are you going to set that equal 0? How are you going to solve that? What would be your first step? Huh? By doing what? Well, before you could cancel out the 10, I'm not sure what you mean by that, but it's square both sides, right? Or, to be honest, how is a square root ever going to be 0 if it's square root of what? What's got to be on the inside for it to equal 0? Square root of 0 is 0, right? So really, yeah, square both sides is fine, but really you could just also say, well, the inside's got to be 0. So 10 minus x squared has got to be 0, right? So you could get that by squaring both sides, that'd be fine, right? And then what? What do you do then? I would add the x squared over or subtract the 10. Either way, it's going to come out the same. But you're going to get x squared equals 10. And so what's x? We talked about it, plus or minus square root of 10. Right? Plus or minus square root of 10. Okay? Now, let's take a look at those. So this would be that parabola. This was a quadratic, so that's a parabola. So there's the two x-intercepts, right? That's what we're talking about. That's the zeros of a function, or the x-intercepts. And on this one, so we got 10 minus x squared equals 0, so x squared equals 10, so plus or minus 10. If you graph that, that's actually the top half of a circle. Okay, but that's fine. We don't need to know that right now. But the two x-intercepts would be plus or minus square root of 10. Now, with this fraction, when is a fraction ever equal to 0? I think we had this conversation already. When is a fraction ever equal to 0? When is a
0.
When the what?
Top.
When the top is 0. Like 0, oops. That was bad. When the top is 0, so like 0 over 4 or something like that. That's when a fraction equals 0, is when the top is 0. So really all you have to do is that. All you have to do is solve the top equal to 0. So 2t minus 3 equals 0, and we just solve that. Okay? We don't care about the bottom. Now, we don't want it to be 0 over 0. We don't want the top and bottom both to be 0. But if that happened, we could have canceled something. Something would have been canceled. So how do we set that one equal to 0? So well, let's just look at their slide. So 2t minus 3 over t plus 5 equals 0. All we do is we just take the top 2t minus 3 equals 0. Now, they said multiply each side by t plus 5. I suppose you could think about that, but why bother? Because then you risk multiplying by 0. Just say, hey, when this is 0 is when the top is 0. And so we get 3 halves. Okay, and here's what the graph of that one would look like right here. And it crosses there. All right, so next thing we want to talk about is even and odd functions. Okay, so we're going to skip a bunch of this stuff here. We're not interested in that. Okay, even and odd functions. Now, didn't I mention these the other day? I think I mentioned these when we were doing our symmetry things. Okay? But basically, even and odd functions are this. Okay? I know what I was going to do. I was going to look at, hang on here a second. Before we write anything more about even odd, I think I had okay. So let's do this. Okay, even functions have y-axis symmetry, so we need to make that connection. So we've already done, so the nice thing about this is it isn't really a new thing because we were doing this the other day. So even functions are those functions that have y-axis symmetry. Now a nice, easy way to remember that is y equals x squared is kind of our, is the one I always think of as an even function. Has y-axis symmetry, and of course the power is even, and so it's a nice way to remember that. Y equals x squared. Even functions have y-axis symmetry. Now on the right, is what we were doing the other day. We were saying, okay, if you put in x, you get out y. You put in negative x, you also get out y. That's y-axis symmetry, right? Remember when we did that? So I'm fine with you continuing to do it that way. So today, my question on today's homework, the question might be, is it an even function or is it an odd function? And it's going to have to do with symmetry. And so we can show it. If it's a graph, you can just talk about the symmetry. If it's an algebra equation, if you have to do it algebraically, we do it like we did the other day. So you put in your y in for y. You put in your negative x in for x, and you simplify it, and sure enough, negative x squared would just be x squared plus 3, and so that checks. That has y-axis symmetry. So that is an even, so this is an even function. That is an even function. Okay? But now let's talk about function notation. What if we're using function notation? So take that same equation, and instead of writing it y equals x squared plus 3, let's write it f of x equals x squared plus 3. Same idea. But oftentimes, even functions are said to contain this property. Now, if you look at this, it's saying the same thing. This is saying that if you put an x in, this is like your y. And if you put a negative x in, you also get y. You get f, right, which is y, and those are equal. So this is really saying the same thing as this. This is saying you put in x or you put in negative x. In both cases, you get out y. They're equal. So you get the same thing out. So what would this look like if you did this? Well, you'd have f of x equals this, and then you would say, okay, well, let's do f of negative x. So that means put in a negative x right there. And so you do it, and you get x squared plus 3. And of course, x squared plus 3 is just f of x. And so what happened? F of negative x is the same as f of x. And so therefore, yes, this is an even function. So I don't care if you continue to do it the way we did the other day. If I give you this function, just change that to a y and write it. No problem. So it's doing the same thing. Okay? So now, let's talk about an odd function. An odd function is one that has, which kind of symmetry do you suppose? Origin or x-axis? Well, remember, what does x-axis symmetry look like? That's x-axis symmetry, right? What's wrong with that? Not a function. So can you have an odd function have x-axis symmetry? No, because it wouldn't be a function, right? So odd function is going to have origin symmetry. Odd starts with an O, origin starts with an O, I don't know. Y equals x cubed is a really good example of origin symmetry. Comes up here, does this, does that. Right? And that's where we said you put in an x, get out y, you put in negative x, you get negative y. Okay? So maybe that's a way to remember odd function origin symmetry. Okay? X cubed is an odd power. So I've just put down an example here to check. All right? And again, we'll do the same thing. All right, so the way we were doing it the other day, we say, okay, here's your original. So now put in a negative y for y and put in a negative x for x and see what you get. You get negative y, let's see, negative x, when I cube it, what happens to the negative? Still there, times that negative would be a positive. And then that'd be a minus x, but now I got to divide by a negative on each side. So that would turn what? This would turn negative, and this would turn positive, and look at that. We get the same thing. We get the same thing we started with. So sure enough, that checks. It's got origin symmetry. Okay? Now, with function notation, it's again very similar. this is saying that if you put in an x and a negative x, you get out y and negative y. In other words, you get out opposite outputs. So what this is saying is if you put in, look at the inputs here, if I put in x and negative x, then I'm going to get out opposites. In other words, I'm going to get f and negative f, right? In other words, the two things will be opposite each other. One will be f, one will be negative f. It doesn't really matter which way that goes. So how does this look? We say, okay, let's put in our negative x here. You know, here we put in a negative x and a negative y. Here we just put in the negative x, and we see what happens. And so we get this. Oops, there we go. Okay, so we do very much the same thing we did before. This negative cubed is going to stay, times that negative will be positive, and we end up getting this. And we look at that and we say, you know what, we can take out a negative there. This is where it gets a little bit weirder. You're like, why would you take out a negative? Well, it's because I'm looking at this up here. But if I take out a negative, we get that. And you say, oh, look at that. That's the same as negative. And then look at this inside here. That's the same as the original I had, f of x. And so what we end up with is negative f of x. So f of negative x is equal to negative f of x. Again, it's the same thing, just notationally it's a little different. Okay, on the quiz, if I ask you, is it an odd function, and you want to do that test for origin symmetry, it's fine. Okay, I just want you to know that odd function means origin symmetry. Okay, all right. We really don't have much else to do. We're gonna, right when we come back, we're gonna do a few together, then we'll mostly have work time. Stop the recording now, boy. All right. Quickly, just a couple of comments here. I want to give you a bunch of work time because the assignment's a little longer. Well, I don't know if it's longer than bad, but so here, I put a bunch of different graphs in here. Just look at it real quick, and I wouldn't worry about writing it down. Just something to think about when we talk about even odd functions, right? So even has what kind of symmetry? Y-axis. Odd has origin. Okay, now, so here I've got just some polynomial functions. Here you have even powers, and look what you have. Even function, right? Got y-axis symmetry. So that's an even function. All right, you have one here with odd powers. Now, does that have origin symmetry? Now remember, what's origin symmetry mean? Origin symmetry means you put in x. Why do I have the ratio? Okay. Put in x, you get out y, you put in negative x, you would have to get out, well, that's a bad example. Let's see, where does that go to up to there? I'm not sure. I went way too far, didn't I? This would go, geez, it even go up there. That was bad. So if I go over about 1.5 boxes, go over about 1.5 boxes, is that origin? What should it do? It should go here, and it should go down here, right? And plus, it's got to go through the origin. Actually, origin symmetry does have to go through the origin. Y-axis symmetry can go through the y-axis, but that doesn't matter. I mean, that's not part of it. But origin symmetry literally is going to have to go through the origin. That's the only way x and negative x can give opposites. Okay, so it's going to have to go through the origin. Now, so you say, well, geez, that's confusing because odd function, that was even. But keep in mind that this plus 1 is really x to the what? That's really like having an x to the 0 there, which is actually an even power. So now all of a sudden when you mix even and odd powers, then all of a sudden you get neither. So this has neither even nor odd, is neither even nor odd, okay? No symmetry. This one, I think that's just x to the first. Those are all odd powers. Not surprising. That is an odd function. That is origin symmetry. Go here and up, over here and down, okay, and so forth. Here you got all even powers, and we talked about a 2. That would be like 2x to the 0. So this should be even y-axis symmetry, and it is. Here you got one, you got a mixture, right? You got odd, you got it even. There is no symmetry with this. There's no origin symmetry. There's no y-axis symmetry. So that's neither. And here you've got one that does have origin symmetry. And again, if you look at it, it's all odd powers. So that's just a little something with polynomials. However, if the problem says to prove that it has origin symmetry, to show algebraically, you still have to put in that x, negative x thing with the y's and do that test for it, okay? especially if it says use an algebraic test to show. But it does give you some ideas here. Okay, another thing very quickly. So what did we talk about doing? We've talked about domain and range a lot today. I'm going to do one more quick little thing with that. We talked about zeros of a function, which is really the x-intercepts. Just take the function, set it equal to 0, and solve. And then we've talked here about even odd functions, and I'm going to talk about these parent functions here real quick in a minute. So if we look at a function here, you don't need to write this down, just talk about this real quick. So what would you say, let's just assume this keeps going forever and ever, what would you say on the domain here? And let's do it with our intervals. Negative infinity to negative 1, 1 to positive infinity, right? The domain. So it's everything but what's in between negative 1. Now, I did something wrong there. I need brackets because we're including the negative 1 and the 1. So I should have brackets there. What about the range?
Y is equal than or greater to 0.
So 0. Now I'm okay if you say y is greater than or equal to 0, or f of x is greater than or equal to 0. I'm okay if you say that, but also you could say this, right? Because the y values, it hits y values at 0, and it's going to go up to infinity. Okay, so just some things like that. On our next quiz, there'll probably be some graphs like this, you know, where you do domain and range of those kind of things. Here, domain would be from negative 4 to 4 is the domain, including the square brackets, and the range would be from 0 up to 4. So you're getting y values that go 0 to 4. Okay, so calculus book said to do range, they said that one way to think of range is if you shined a light from the side, the range would be the shadow that would be on the y-axis. I thought, well, that's kind of an interesting way to say it. So if the light shines here, it's just going to go right on through, right? But right here, the light would hit this, and so there'd be a shadow on the y-axis all the way from here to here. And then, of course, up here, the light would shine on the axis. That's kind of an interesting way to think about range. So, for example, on this one, right? You shine the light, where's the range? Well, there'll be a shadow. It'll hit these parts. So starting down here at negative 4, all the way, and assume that goes up forever from negative 4 on up, you would have the range. If you look at a piecewise type function, I think we got one here. Okay. What about this one? The domain would be what? Again, assume there's arrows here. All reals, because it'd be negative infinity. Here, there's this output, and it would keep going. What about the range? What about the y?
Y is greater than -2.
If you think, now again, think about this thing with the shadow. So if I shined a light, the shadow would be on this, shine a light from this side all the way to here, and then also you get a shadow here. So all the y values really are taken from -2 all the way up. So greater than -2 or -2, -2 to infinity, right? Now, another question that you'll be asked on your homework with a problem like this, what is f of 1 on this graph? What is f of 1? That point right there. What does f of 1 mean? Plug in a 1. Well, there's not an equation to plug it into, but what do you get out? What is the y value? So you plug in a 1, and you get a y value of 1, right? Because that's where it's filled in. If this was filled in and this was open, then it would be -2. Okay? So when you have a graph and it says, what's f of 1? That's just saying, go to the graph, go to 1, what's the y value? It should only be 1 if it's a function. It should only be 1 value. All right, last thing that you might want to jot down. These are in your book. These 8 basic functions, they are listed on page 7. These 8 are listed on page 7, right? You can take a picture of it. I'm going to leave this up here. You can take a picture of this, or you can write it down. Either way, whatever. But if one of the things we want to be able to do is identify and know which basic graph goes with each basic function. Okay? So, f of x equals a number, c, just a constant, that's a horizontal line. Okay? A linear, now they call this one the identity function. If it's y equals x, then it's the identity because the x and y are identical, right? 1, 1, 2, 2, 3, 3. But any linear, I put up here f of x equals mx plus b. So recognize a linear equation if you have x to the first. Absolute value is the b graph. Okay, this is one you're not as familiar with, probably the square root graph. We did talk about how sideways parabola is not a function, but if you take just the top half of it, that's the square root function. Okay, so if you take x equals y squared, which is a sideways parabola, square root would be the top half of that. So that's one you probably have to think about a little more. Of course, quadratic, your book calls it the squaring function, but that's also known as a quadratic function when it's x squared. That's a parabola. Your basic cubic looks like that. Okay, the reciprocal function is another one you're maybe not as familiar with, the 1 over x function. That graph has a special name. That's actually called a hyperbola, something we're going to study later in the year. Okay, but understand that. Just kind of be good to know that. And then this last one here, the greatest integer function. It's got these double square brackets around the x. Anybody ever heard of this one? Do you guys do that? Okay, I didn't think so. I call it the rounding down function. Okay, I call it the rounding down function. And what it does is this. Just what the name says. It rounds down. So if I put in (1.2), the answer to that is 1. If I put in 1.7, the answer to that is 1. It rounds down everything. 1.9 would be 1. 1.99 would be 1. But then when you get to 2, then it's 2. So it rounds down to a whole number. So if you look at the graph, it kind of makes sense. 0 would round down to 0. 0.1, 0.2, 0.3, 0.4, 0.5, all the way to 0.9, rounds down to 0. But then when you get to 1, it jumps up to 1. 1.1, 1.2, 1.3, all the way to 1.9, rounds down to 1. And then at 2, it jumps up to 2. Make sense? Sometimes called a step function. Okay, it's definitely a piecewise kind of function, right? But that's called the greatest integer function. So there'll be some homework questions where they'll give you a greatest integer function. They'll tell you to plug in a 1.2 or a 2.7. Now, what's interesting with negatives, if you have negative 1.2, what's that round down to? Negative 2, right? It rounds down. So negative 1.2. So if you come over here to negative 1.2, notice it's got a value of negative 2. That would round to, it rounds down. Okay, and so from negative 1 to negative 2 is going down. So negative 1.2 rounds down to negative 2. Okay, that's called the greatest integer function. All right, so your homework, I'm going to go on. Again, these are listed on page 70. Okay, so you can get these on page 70. So those are that's the homework. 80, I'm gonna change this. Not change it, but a little additional direction. On 84 through 90, this is odd even questions. Okay, show algebraically. It doesn't say it in the directions, but that's what they intend. Okay, that's where you do your x, negative x, that kind of stuff. Okay. Now, in the other ones, 10 through 32, even, and those kind of things, it's a lot of stuff with domain, range, and finding zeros. Okay, so the first two things on our list for today, domain, range, finding zeros. Okay, they give you some graphs, give you some equations. Show algebraically. On these, I'm going to say go ahead and graph those on Desmos and look at those and get your even odd answer. Okay, based on that. Now it says in the directions to verify those algebraically. You don't need to do that. You can do that up here. Now it's not bad practice, but you don't have to do it on that many. I think you do it on these, that's enough practice. Okay? So on 91 through 100, you can graph and tell if they're even odd. And you don't have to worry about verifying algebraically.